what the slope would be for a line, two lines that are parallel or two lines that are perpendicular. Okay, so as a refresher, let's remind ourselves what parallel lines are. Who can tell me?
Lines that never touch.
Yep, they never intersect. Right? So we have like a line like this and a line like that. Probably when you were in elementary school, your teacher was like railroad tracks or like sides of the road are never going to intersect, right? Like, you're going to keep going forever and ever. Median divides it, okay? I always told my fourth graders, like, there is parallel lines in the word parallel, right? The two L's, yeah? Helps, okay? So the other type of lines are perpendicular lines. Who remembers what perpendicular lines are? Jackson? They cross very specifically at a
90-degree.
Yes. Cross at 90-degree angle. So you're going to have something that looks like this. Okay. So we're going to be talking about what do the equations look like for two lines that are parallel and two lines that are perpendicular. Okay. Any questions so far? Nope. Okay. So we're going to jump into examples. Well, I have enough. Do you guys have any graphs in your binders?
Yeah.
Does everybody have two graphs?
Yeah.
Yeah?
I have two.
Everybody has two? That's perfect.
I think I'm away.
Well, why would you do that?
I
I don't think I said throw away the graph.
You get an option to go to where it says go.
I don't think I said that.
I thought you said save.
I swear.
I thought you did it.
I'm pretty sure I threw mine away. That's okay. If you need a couple graphs, they're going to have to be yellow. But you can take two and pass them on to me.
Wait,
You're also going to need glue sticks, right?
How many do I need? Two?
Get yourself a glue stick. Anytime decision.
Hey, could you grab one? Oh, no, you're adding glue. Right here. Don't give it to Alan. Great. Could you grab? Where's the gas? Oh, you really tricked me, trickster. Wait, my glue stick's dead. Don't store it. Wait, I get all the colors. I feel like this side always comes hey.
Don't do anything yet. Wait for instructions. Don't do anything yet. Okay. Sorry about that, but I think this will work out better if we have actual graphs. Are there any more yellow ones? There's some yellow ones in the back. Yep, Nolan has them. Okay. Here we go.
Does anybody still need these? Oh, yeah. We can't just be. I thought there was the
Okay.
I think that's everything.
Thank you.
I don't know.
Okay, so we're going to start out with a linear equation. This one happens to be, what form is this in right here? Standard. So we're going to change it to slope-intercept, which we're all pretty good at this point, where we would subtract 3x from both sides. Don't glue anything in your notebook yet, guys. Just wait until I give more instructions. Remember, we're going to sneak the 3x right there in front of the 12. So now we have 4y equals negative 3x plus 12. And then we'll divide by 4 each term. And we get y equals negative 3/4 x plus 3. So what we're going to do is we're going to glue our graph in over here. Please try to put it in roughly the same spot that I do. It'll make sense in a second. Okay, then we're going to, guys, we're moving on. Lots of conversation going on. We've got to keep moving. So now we're going to actually graph this. So I'm going to put my y-intercept at 3. My slope is negative 3 over 4. Then I would go up 3 and back 4. And that's all I can put on my paper. So then I'm going to graph this. Right, so my slope is negative 3 over 4. Our y-intercept was the 3. So we plot it at the y-intercept. Down 3 over 4, up 3, back 4, because we have to go in the opposite direction. Okay, now I'm just going to give you an equation that's already in slope-intercept form. And we're going to graph that line. So I gave you y equals negative 3/4 x minus 2. So right away you should notice something about these two lines. They're parallel, right? They're not the same line because they have different y-intercepts, but they're parallel. So what do you notice about these two equations?
They have the same slope.
Same slope, right? Slope equals negative 3/4. Slope equals negative 3/4. So our rule for parallel lines is they will have the same slope. So if you're trying to determine if two lines would be parallel, put them in the slope-intercept form, compare the slopes. If they have identical slopes, that means they will never intersect because they are changing at the exact same rate. So that's the easy part, the parallel lines. Parallel, same slope. Right? Next page. So same thing. We're going to take this equation, we're going to change it into slope-intercept form. So I would subtract the 5x from both sides. Now I have 2y equals negative 5x plus 6. Divide everything by 2. Then I'll glue in another piece of paper, another graph.
Does that slope say 2/5?
It does. So once you have both of those, I just gave you one in slope-intercept. I gave you one that you had to convert. When you graph these two lines, you notice that they are perpendicular, which you could have predicted. But what happened? What is it about the slope that would tell you right away these are going to be perpendicular lines? How can you describe what's happening between this slope of negative 5 over 2 and this slope of 2/5? What happened? Avery? That's part of it. They're opposites. One of them's positive, one of them's negative, so they're opposite. What else happened?
The numbers flip-flop.
The numbers flip-flop. What's the fancy name in math for when you... Reciprocal. So perpendicular lines have opposite reciprocal slopes, meaning they're going to go from positive to negative, and the numbers are going to flip-flop. Okay? So perpendicular lines opposite reciprocal slopes. No, I don't want that in there. And that's just always going to happen. Doesn't matter what the y-intercept is. We're only focusing on the slope for these kinds of relationships. So we're going to do a little practice here. I'm going to give you two equations written in slope-intercept form, and you're going to tell me if they are parallel lines or perpendicular lines. Just looking at the slope. Practice number 1, parallel or perpendicular?
Parallel.
Why?
Same slope.
Yep. Same slope, parallel. Parallel or perpendicular? Ah, I tricked you. Neither. Who was thinking neither?
Me, I actually was.
What's missing? It's not opposite, it's just the reciprocal. So neither. Not opposites. Right? It has to be opposite and reciprocal. It can't just be one. Y equals 5x plus 7. Y equals negative 1/5 x minus 3. Parallel, perpendicular, or neither? It is perpendicular. Opposite reciprocals. Raiden, can you see okay over there?
Yeah.
Like, you can actually read what's on the screen? Okay. Parallel, perpendicular, or neither? Neither. Why not? There's no reciprocal. There's no reciprocal. Good. You guys feeling good about this?
Yeah.
Of course you are. All right. Keep this out. Well, yeah, keep it out. You need a couple pieces of blank paper.
You want us to pass the rulers down?
Yeah, you don't need your ruler. You can pass it down.
A reciprocal if it's 2/5, and then there's 5/5.
So when you graph it,
Do we need any graphs?
Not for this, no.
I banked it. I put it in these favors. Are there any more? Which drawers do you want?
Top one. Thank you.
This one? What's your middle name? In here, McKenna. Oh. Oh my gosh.
Okay. So we're going to take this to a slightly extra level. So we have this practice page here.
We have an extra apparently.
Thank you. Oh, thank you. Okay. We have about 10 minutes. I'd like to get at least 3 of these done. All right. So for question 1, it says, write a linear equation in slope-intercept form of the line that passes through this point and is parallel to this. Okay. So what do we need for slope-intercept? What do we need?
A slope and a y-intercept.
Slope and y-intercept. So on your paper, like your lined paper that you have ready to go, put number 1. So if I want it to be parallel to this line, what will my slope have to be of the new one? The same. Okay. I want to write it in slope-intercept form, but all I have is a point and the slope. So how am I going to write this and then convert it into slope-intercept form? Point slope form?
Yeah.
Right? So y minus y1 equals m times the quantity x minus x1. Yeah? So I have the slope. I have my point and a slope. So now I'm going to work this out. Y minus, remember my point is 5, 2. Y minus 2 equals 3/5 times the quantity x minus 5. So now I'm going to distribute this 3/5. Y minus 2 equals 3/5 x minus 3. Then I'm going to add 2 to both sides. Y equals 3/5 x minus 1. Ta-da! So then over here on my paper, I'm going to write y equals 3/5 x minus 1. Yay! So there's a couple things to pay close attention to. First, the information that's given, specifically if they want a line that is parallel or perpendicular. Because if they had wanted a line that was perpendicular, what would my slope have been? Negative 5/3, right? Because it would have been the opposite reciprocal. Okay, so let's look at problem 2. We're just going to keep working through. Don't get ahead of yourselves now. No. Nope. Write a linear equation in standard form. We have a point. We have the slope. We still want it parallel. So let's pretend number 1 needed to be in standard form. There's only a couple other things we would have had to do. What would we have done to take this then to standard form? Jackson? subtract 3/5 over here, and then
-1.
we would have to multiply it by -5 to clear the fraction, because that's the denominator, right? So let's do problem number 2. Our slope is still going to be the same that's given, so -6 over 5, because it's parallel. And our point is -5, -5. So we're going to go through the exact same process, except just extra step at the end. Yeah? So y minus y1 equals m times the quantity x minus x1. And these turn into positive 5s because minus a negative is a positive, right? So y minus -5 is going to be +5. X minus -5 is going to be +5. So then I get y plus 5 equals -6/5 x minus 6. Add 5 to both sides. Y equals -6/5. Sorry, subtract 5 from both sides. Yes, thank you. Then we add 6/5 to both sides, 6/5 x. Just have one last step. Can't be a fraction, so how am I going to get rid of that fraction? Multiply everything by 5. 6x plus 5y equals -55. There's our standard form. Ta-da! Okay, we're going to stop right there. We aren't going to get the third one done because we have to talk about other things right now. So just put this in your notes, like put it behind where we left off in our notes. Don't lose anything.
When are we gonna update our teacher?
Oh, I don't know. Maybe tomorrow.